This is section 2-3, the product and quotient rule. This is the basic definition of the product rule. If you've got two functions, u and v, and you want to know the derivative of u times v, it simply is equal to the derivative of the first times the second plus the derivative of the second times the first. So derivative of uv is simply equal to u prime v plus uv prime. Okay? So let's look at an example. Let's say we've got a function 2x plus 1 times x minus 3. First of all, if we were to simply FOIL this out, this is one way we could do the derivative. So if we just FOIL 2x plus 1 times x minus 3, we get 2x squared minus 5x minus 3. And then we could just simply go down the line. The derivative of 2x squared is 4x. The derivative of minus 5x is minus 5. And the derivative of minus 3 is 0. And we'd get the derivative as being 4x minus 5. Now, however, if I used the product rule, which we got up here, of u prime v plus uv prime, where this first term is u, so this would be u right here, and the second term is v, and this would be v right here. So its derivative of the first, well, derivative of 2x plus 1 is simply 2 times x minus 3, plus 2x plus 1 times the derivative of the second. Well, the derivative of x minus 3 is 1. If we distribute and then combine like terms, what do we get? We get 4x minus 5, which is the same thing we got before. So these are two ways that we could have done this derivative. We could have just multiplied it out and done the derivative that way, or we could use the product rule. So now let's look at the quotient rule. Instead of being u times v, what if we have u divided by v? Well, in that case, it looks very similar. The numerator looks very similar to what we had before, in that it's going to be the derivative of the numerator times the denominator, but now minus the numerator times the derivative of the denominator over the denominator squared. So it's u prime v minus u v prime over v squared. So let's look at another example here. Let's say our function is 2x plus 1 over x minus 3. So the numerator, which is u, is the 2x plus 1. The denominator, which is v, is x minus 3. And let's see how we'd use the quotient rule to get the derivative of it. All right, so let's do u prime. So that's the derivative of the numerator. Derivative of the numerator is simply 2 times the denominator, which is x minus 3, minus the numerator, 2x plus 1, times the derivative of the denominator, which is simply 1. And that's all over the denominator squared. So that's x minus 3 squared. All right, distribute, we get 2x minus 6 minus 2x minus 1 over x minus 3 squared. Combine like terms, and we get the derivative of this is simply equal to minus 7 over x minus 3 quantity squared. So let's look at more examples. Let's say we've got a function here of 3x squared over 2x plus 5, all right? And this is a quotient, so we're going to use the quotient rule. So derivative of the top, which is 6x, times the bottom, which is 2x plus 5, minus the derivative of 2x plus 5, which is simply 2, times the top, which is 3x squared, all over the denominator squared. Distribute, combine like terms, and we come out with the derivative of this function is 30x over 2x plus 5 quantity squared. All right, let's look at another example. Let's say we were asked to find all horizontal tangents for this same function that we talked about in the previous slide here. So we got y, or f of x, or however you want to write it, is equal to 3x squared over 2x plus 5. So we want all horizontal tangents. So therefore, we want to know, where is this graph? Is the slope of this graph, the instantaneous slope of this graph, equal to 0? Well, if I take the derivative, remember from the previous example, the derivative is simply equal to 30x over 2x plus 5 quantity squared. Well, where is that equal to 0? That's equal to 0 where the numerator is equal to 0. And in this case, the numerator is equal to 0 when x is equal to 0. So the horizontal tangents occur where x is equal to 0. X is equal to 0, you plug it in over here, and you find that y is equal to 1/5. So at the point x equals 0, y equals 1/5, we have a horizontal tangent, okay? So that's another way of looking at derivative or slope. So let's look at some more examples. Let's say we were asked to find find f prime of 4 given the following. Okay, so we're given g of 4 is equal to 3, g prime of 4 is equal to -2, h of 4 is equal to -1, and h prime of 4 is equal to 5. And we're asked to find f prime of 4, okay? So we're given various examples here, so let's look at each one individually. All right, so let's look at the first example here. We've got f of x equals g of x minus h of x, all right? Now, remember, we are asking you to find f prime of 4. So the first thing I'm going to have to do is take the derivative of this expression. So f prime of x is simply g prime of x minus h prime of x. So therefore, f prime of 4 is going to be -2, which is g prime of 4 up here, minus h prime of 4, which is 5. So it's going to be equal -2 minus 5, or simply -7. So let's look at the second one. It says f of x is equal to h of x plus 2. Well, the derivative of f of x is simply f prime of x is equal to h prime of x. Derivative of 2 is 0, so we're simply saying f prime of 4 is equal to h prime of 4, or f prime of 4 is equal to 5. Now I've got f of x equals g of x minus 2 times h of x. So if I take the derivative, I get f prime of x is equal to g prime of x plus 2 times h prime of x. Or f prime of 4 is equal to -2 plus 2 times 5, or the answer comes out to be 8. All right, now we get into the quotient and product rule. So we've got f of x equals h of x over g of x. So f prime of x is going to equal derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator squared. So if we plug in for all of these, which we've all got up at the top here, we get this expression down below, which simplifies simply to be 13 over 9. And lastly, we have the product rule here. F of x equals g of x times h of x. So f prime of x is going to equal g prime of x times h of x plus g of x times h prime of x. Plug in the values. F prime of 4 comes out equaling 17. So this is just another way of looking at derivatives, values of derivatives, and the like.